there! Now, I have a glass of water with me and ooh, I accidentally dropped some fruit in it. Now, this is a little test. What happens if I stir it? It doesn't dissolve. The fruits, they stay on top. The seeds, they stay on top. But, now if I were to add some sugar to it, you will see that at first, it stays on top, but you can see it falling down. And if I were to stir it, look at that, it slowly dissolves. Now we're back to the fruit, water, seeds, but now with the sugar dissolved in it. Can any of y'all tell me why that happens? No? That's fine. Because today, in our book, we're going to be reading about the states of matter and how they change. Can any of y'all tell me what the states of matter are? If you don't know, totally fine. That's what we're going to be learning about. This is our topic for today. We will be reading this book. Now, will y'all join me, will you? Our book today will be Matter and How It Changes, made by Joseph Mithun, and some of the illustrations are by Samuel Hitti. Have you ever wondered how water turns into ice? When you fill up a tray with water and put it into the freezer, the water changes from a liquid to a solid. This is just one of the many ways that matter can change. But what, may you ask, is matter? Oh, where are my manners? I'm matter. Everything in the world is made of me. Before we can look at ways that matter can change, we need to know what matter is made of. Lights. Thank you. First slide, please. If you look inside, you'll see that I am made of tiny particles called atoms. Have you guys ever heard about atoms before? Do you think that you could define an atom? Let's find out if you're right. Atoms are the basic units of matter. When atoms bond together, they form molecules. Lights, please. Let's take a closer look at ice. It's made of molecules of 2 hydrogen atoms and 1 oxygen atom, just like liquid water. So, how come the frozen solid and not a liquid? Simple. Matter can change states or forms. There are 3 basic states of matter: solids, liquids, and gases. The molecules in a solid vibrate. They are arranged in a repeating pattern like soldiers marching together. The molecules in a liquid move more freely, like people walking in a large group. The molecules in a gas are faster. They move even more freely, like people skating in a park. Since we know what the states of matter are now, what states of matter were in my cup at the beginning of the video? The fruit pieces were solids, the water was a liquid, and the bubbles from stirring were gases. Okay, the next sections of this book are about heating and cooling matter and the changes between them. Those topics are not what the focus for today is about, so I will be skipping over them. But I will leave the pages on the screen if you'd like to pause and read them. A change of state is an example of a physical change. The matter may look different, but its properties are still the same. It's still made of the same materials. If you crumple up or tear a piece of paper, you physically change the paper. Paper comes from trees. When I chop down this tree, timber! It changes from a tree into a log. Crash! I can carve this log with a chainsaw. Rrrr! Now, all that's left is some sawdust and a toothpick. The tree has just undergone a few physical changes, but it is still wood. After learning about physical changes, can you guys think of any other physical changes that you've seen? I can think of a few examples. Getting your hair cut, freezing water into ice, like at the beginning of the story, or breaking a pencil in half. Do you think that the sugar mixed in with the water from the beginning was a physical change? If it's not a physical change, then what do you think it was? Let's find out! We can also cause physical changes by mixing matter together. Mixtures are physical combinations of substances. Mixtures can be made of a combination of solids, liquids, or gases. A sandwich is just a simple mixture. Just think, you're combining bread, vegetables, and cheese together to make a lunch. Other examples of mixtures like the sandwich are a bowl of vegetables, a box filled with different toys, and the fruit in the water from earlier. That's right, that the fruit and the water are a mixture. But is the sugar and the water a mixture? Let's see if the story will answer our question. Some mixtures are more complex, like this ocean water. The movement of the ocean keeps water and sand evenly mixed, but if the water is kept still, the larger pieces of the sand will settle to the bottom. This kind of mixture is called a suspension. A suspension is kept mixed by the movement of one or both substances. When the substances are separated, they are no longer a suspension. Now, does the sugar in the water from earlier look like the suspension talked about in the book? No, not quite. Then what could it be? Let's see if our answer is on the next page. Some mixtures can be separated as easily as they were combined. Others can be separated with a little help. For example, you could filter out the sand from the water, but there's another kind of mixture that is more difficult to separate. Ocean water is a mixture of salt and water, but you can't see the salt because it has dissolved. This means that it is mixed evenly into the water. This kind of mixture is called a solution. No matter how still you keep the water, the salt will never settle to the bottom. To separate the salt from the water, we need to wait for the sun to evaporate the water. The solution has been separated. The salt is left behind. Agua. Our sugar and water experiment earlier is just like the salt in the water solution in the book. So this means that the sugar mixed in the water is a solution. The sugar was dissolved by the water, and this made it evenly spread out in the water. That's why it is a solution. Alright, the next section is about chemical changes, which doesn't involve our topics for today, so I will skip over that part, but it will be on the screen if you'd like to still read it. Matter changes around us all the time. Can you think about where you've seen matter change in your day-to-day life? How about steam coming from radiators, or even smoke from a chimney? Or what about food? Have you ever seen someone bake bread? What happens when you put the dough in the oven? Why do snowplows salt icy roads in the winter? The salt helps make the ice melt by preventing the water molecules from sticking together. This keeps them from turning into ice. If we didn't understand the basics of how matter changes, we wouldn't be able to do any of these things. Did you know that matter changes everywhere around us? There's always change, and that's why there's so many mixtures and solutions in our world. If you guys didn't quite understand some of the bolded words in the video, here are the definitions. You can pause and read them if you need. And if this book made you more curious about matter, here are some other books that cover this topic. Hey everyone! Thank you for joining me as I read this book to y'all. So, what'd you think? Did you learn more about matter? Did you learn more about mixtures and solutions? Did anything new stick out to you? Or have you learned about all this before? Let me know what you think in the comments below. Y'all have an amazing day.